All right, in this problem, we are required to determine the molecular formula of a drug with the composition 49.4% carbon, 7.64% hydrogen, 17.7% nitrogen, 15.2% oxygen, and 10.1% sulfur. And there are 5 elements here, so this is involved. Now there is another detail. 0.01 mole of the drug has a mass of 3.16 gram. Now determine the molecular formula of the drug. We want the molecular formula. So this involves stages of calculation. We're going to use this percentage composition of these elements to obtain the empirical formula of the compound. So stage 1 of this calculation is to obtain the empirical formula. We have the empirical formula to be found. We're going to obtain the empirical formula in the first stage. And in the second and final stage, from the empirical formula, we obtain the molecular formula. The molecular formula. But before that, there is the intermediate stage where we have to determine the molar mass of the compound. So the molar mass. And that is a stoichiometric calculation, making use of this fact that 0.01 mole of the drug has a mass of 3.16 gram. We're going to employ the fact that 1 mole of the drug has a mass equal to the molar mass. So we're going to convert 3.16 gram in 0.01 mole into what mass is present in 1 mole. So we obtain the empirical formula, obtain the molar mass, and in the final analysis, determine the molecular formula. Let's get straight off into the solution. But we need these traces away. Straight off into the solution. We use the tabular format to determine the empirical formula. So let us have a table. I like to take that away because there are 5 elements here, so we really need plenty of space. I have to manage the space. So let's go for this. All right, let's get into it. So we have the elements. And then the percentage composition. There are 5 elements in this problem, so let us list them. Carbon, hydrogen, nitrogen, oxygen, and of course sulfur in the order in which they occur. So there are individual percentage compositions. We have 49.4 for carbon. We have 7.64 for hydrogen, 17.7 for nitrogen, 15.2 for oxygen. Last but not the least, 10.1% for sulfur. Now in the next stage, we determine the relative moles present. Relative moles of atoms. The relative moles of atoms present. And that will involve dividing the percent composition by the individual relative atomic masses, not the molar mass. So let's get into it. That means for carbon, we're going to have 49.4 divided by the relative atomic mass of carbon, which is 12. Upon evaluation, this will give us to 2 places of decimal, we have 4.11. The next one, 7.64. Divided by the relative atomic mass of hydrogen, which is 1, not the molar mass, which would have been 2, but the relative atomic mass. So 7.64 divided by 1 returns 7.64. Now for nitrogen, we have 17.7 grams of nitrogen, 17.7 grams of nitrogen. On dividing by the relative atomic mass, which is 14, we have the 2 decimal places, 1.26. Next is oxygen. The mass of percent composition of oxygen is 15.2. And now by dividing by the relative atomic mass of oxygen, which is 16, we have the 2 decimal places, 0.95. Finally, for oxygen, 10.01. And if we divide by the relative atomic mass for sulfur, which is 32, to 2 decimal places, we're going to have 0.32. What's a value? 0.32. Exactly, modification of the bottom. All right, we have the relative moles of atoms. Now we have to convert this to simplest ratio by dividing by the smallest. So division by the smallest leading us into the simplest ratio. So let us obtain the simplest ratio in which these atoms are combined. All right, we're going to have to divide by the smallest. The smallest of all these values is right there, 0.32. We've got it. That's it. And now we have to divide by that. So all values divided by 0.32. We have 4.11 beginning divided by 0.32. This gives us 12.84 to 2 places of decimal. And now let's just hold that for the moment. Now we're going to divide the next one, 7.64. Also divided by the smallest, which is 0.32. And this gives us 23.88. We continue in that manner. 1.26, the next value. Divided by that smallest value, 0.32. Gives us 3.94 to 2 places of decimal. And now 0.95. Also divided by 0.32. Gives us 2.97. Finally, 0.32 divided by itself, 0.32. Gives us 1.00. Now, it is reasonable to take these values to the nearest whole numbers because they are significantly close to their nearest whole numbers. 0.84 very close to the nearest whole number. So let's have that. 12.84, nearest whole number 13. 23.88, nearest whole number 24. 3.94, nearest whole number 4. 2.97, nearest whole number is 3. And finally, 1.00, of course, we have it is an absolute figure, which is 1. That's right. Now, this gives us the simplest ratio of combination of the atoms. And that's the empirical formula can be written from here right now. Therefore, we have the empirical formula. The empirical formula can be written. Simply, it is carbon 13, hydrogen, of course, 24, nitrogen, 4, oxygen, 3. And finally, sulfur 1, which we do not necessarily have to write. This is the empirical formula of the organic compound, the drug. All right, now let us go to the next stage. The second stage of the calculation is to use the value 0.01 mole of the drug has a mass of 3.16 grams. The question then is, what will be the mass of 1 mole of the drug? And that mass is the molar mass. Let's get straight into it. Of course, this phases we have to go away. Let us take note of our empirical formula. We're going to need it in the third stage of the calculation. C13H24 N4O3S. Let's go. The traces out of the way. Now, this is a stoichiometric calculation. What will be the mass of 1 mole of the drug? So we start straight off with this, and we use the dimensional analysis technique. We say 1 mole of the drug. 1 mole of the drug. 1 mole of drug, and then we multiply, aiming to cancel out the unit on the left, mole of drug. And the detail provided is 0.01 mole of the drug, so we can employ that. 0.01 mole of the drug has a mass of 0.01 mole of the drug has a mass of 3.16, so 3.16 grams. Beautiful. And now it means these units can cancel out. Mole of drug out. And the prevailing unit is gram of the drug, which is the molar mass. Upon evaluation of this value, we obtain the molar mass. So with an electronic calculator, we can divide, simply move the decimal point twice below and move twice up. We have 316 gram per mole as the molar mass of the drug. Beautiful. Now we have the molar mass. We can go into the third stage of the calculation, which is to use this molar mass in combination with the empirical formula to determine the molecular formula. Of course, our operating principle is that the molecular formula is an integer multiple of the empirical formula. Here we go in the next stage. This trace is out of the way. Now let the molecular formula be an integer multiple of the empirical formula, of course. So we have this B, our empirical formula. We have it already. C13, H24, N4O3S. Now we have to append N, where N is an integer. And then we need to determine N to obtain the molecular formula. Now we know our molar mass already, so let us calculate the molar mass. Therefore, we have, since the N is multiplying all atoms here, we can single it out of this square bracket. So we begin. There are 13 carbon atoms present in this compound. So we have relative atomic mass of carbon is given to us right there, 12. Multiplied by 13. The number of atoms of carbon present. Plus the next hydrogen occurs 24 times. Relative atomic mass of hydrogen given is 1. Multiplied by 24, the number of times it occurs. Plus the next one, nitrogen. Relative atomic mass of nitrogen is 14. Now multiplied by the number of times it occurs 4 times. Plus the relative atomic mass of oxygen is 16. Multiplied by the number of times it occurs 3 times. And finally, plus the relative atomic mass of sulfur is 32. And it occurs only once, so we can close and seal up our bracket. All of this equals the molar mass, which we have already as 316. Now let us evaluate the units within the brackets. Therefore, we have N into 12 multiplied by 13, we can have that. 12 multiplied by 13, we can have that there. 12 multiplied by 3 is 36. And I have taken 3 over. 12 multiplied by 1 is 12. Plus the incoming 3 is 5. So I have that. 156, of course. Plus 1 multiplied by 24 gives us 24. Plus 14 multiplied by 4 gives us 56. Plus 16 multiplied by 3 gives us 48. And plus 32. All of this will give us 316. And now we have to add all these values within the bracket. And therefore, we add up these values. We can add digit by digit, of course. 2 plus 8, that's 10. 10 plus 6, 16. 16 plus 4, 20. And then plus 6, that's 26. And that's it. Taking 2 over into the next result. 3 plus 4, that's 7. 7 plus 5 is 12. 12 plus 2 is 14. 14 plus 5 is 19. And 19 plus incoming 2 is 21. 1, taking 2 into the last digit. Last digits, these ones don't have the last digit, it is 1. 1 plus the incoming 2 gives us 3. And now we can append the n. This gives us, on the right-hand side, 316. I just want to show how to do this without a calculator, simple additions. Now let us divide both sides by 316 to isolate the n. That's right. Divide both sides by 316. And of course, 316 divides through, and 316 divides through to give us finally n equals 1. And this is a special case where the empirical formula now equals the molecular formula. So we can write, and therefore our original molecular formula, the molecular formula can now be defined. Molecular formula is C13, H24, N4, O3 with S, multiplied by N, which has now been determined as 1. For an evaluation, we have C13, H24, N4, O3, S, our final answer. And this is very simple and beautiful. And that's the option B right there. That's right. Now, attached to this video are 2 quizzes, which I encourage you to attempt in order to test your understanding of the content of this video. In addition to that, there is a link provided in the pinned comment that takes you to the test on chemical composition stoichiometry. There are 20 questions to be attempted in 30 minutes. I encourage you and I highly recommend you take the test to establish your mastery or your understanding of the topic, chemical composition stoichiometry. Finally, if you are sure you intend to study the topic fully, there is a full presentation of the topic in the link attached in the pinned comment. It takes you to the full presentation of the topic, chemical composition stoichiometry. Enjoy studying and learning it and have fun. Thank you for being part of this session. And I look forward to seeing you, of course, in my next video.